In this video, you'll see how to integrate scripts into AWS Systems Manager automation documents to create runbooks. With this capability, you can define scripts to be executed, include them as steps in automation runbooks, and incorporate these runbooks for efficient operations management. To get started, let's navigate to Systems Manager. We're going to examine and execute 3 different automation documents. First, we'll create and execute a custom automation document. Our document will send a message to a user-specified Amazon Chime chat room through its corresponding webhook URL. We can define the input attributes, target type, and document tags. In this case, let's require that a meeting room webhook URL and message content are specified upon each execution. Systems Manager documents, or runbooks, are composed of individual steps that perform a variety of functions. For this simple automation runbook, we'll specify only one step that sends a message to the webhook URL provided by the user. To do this, we'll run a script. Next, we'll specify the execution runtime, the script code itself, and the handler. Let's replace the sample Python code with our script. This code imports a Python HTTP client library called requests. You can download these packages from the Python package index or a package management system such as Conda. We'll need to provide the packaged code for the library as an attachment to the step. Attachments can be either uploaded or pulled from an Amazon Simple Storage Service or Amazon S3 bucket. We'll specify an S3 bucket URL to host the contents of our packaged library. Next, we'll specify the input parameters that will be fed into the request. Now let's create the automation runbook. Custom runbooks appear on the Owned by Me tab. Here we can see the YAML specifications for the document. Let's execute it. As expected, we're prompted to provide 2 input parameters. Let's open Chime to get the webhook URL. Now we'll provide a sample message and execute the runbook. Let's open Chime to ensure our message went through. As you can see, our automation runbook successfully sent a message to the chat room. Automation runbooks, whether customized or provided by AWS, can be used as building blocks in larger automation documents to enable more complex workflows. Let's look at an example that uses the custom runbook we just created in one of its steps. This automation runbook takes 2 inputs upon execution from the user: a Chime chat room webhook URL and the instance ID of an EC2 instance to be restarted. The first step is defined as an execute automation action, which allows for already defined automation runbooks to be used. Let's look at the inputs. This step uses the automation runbook we created earlier to send a message to a Chime chat room before rebooting the instance. The webhook URL is left as an input to the user, while the message content is predefined. The second step uses an AWS-provided automation runbook to reboot a specified EC2 instance, passing the instance ID input as a runtime parameter. The final step, which is similar to the first step, sends a message to the chat room after the reboot has finished. Let's execute the automation runbook. We can see the EC2 instance stop and then restart. Now, let's open Chime to ensure that the pre- and post-reboot messages were sent to the chat room. As you can see, the messages were sent successfully. The final runbook we'll execute is a more complex automation document consisting of several script execution steps. This runbook targets specific EC2 instances in our account to perform patching, if needed. It lets customers choose which instances to patch or exclude by specifying the right tags. It also restarts stopped instances for the purpose of patching and puts those back into the stopped state after patching. Most steps in this document perform an execute script action, allowing a complicated workflow to be executed easily. Let's view the inputs for the first step. A Python script filters EC2 instances in our account based on key value pairs provided as inputs upon execution to identify instances that should be patched. It excludes instances that belong to a specified tag. The second step runs a script to identify which instances among those filtered by the first step are in a stopped state. The third step then runs a script to start these stopped instances. The fourth step performs the patching operation on all of these selected instances using a run command action. The final step stops any instances that were restarted for the purposes of patching. Let's run the automation. This automation document takes 3 input parameters: a tag key value pair to filter for EC2 instances, a second key value pair to filter out instances that should not be patched, and an AWS Identity and Access Management, or IAM role, that allows automation to make changes to the EC2 instances. Again, we can see the EC2 instance stop and then restart. All 5 steps were executed successfully. You've just seen how to integrate scripts into AWS Systems Manager automation documents to create efficient runbooks. Thanks for watching. Now it's your turn to try.